We're going to the next speaker, which is Christian. And Christian is continuing on this topic, but more on the side of what can we do if we have these key pairs on the device. Christian has been active in the RIOT community for quite a while, is active in the IETF community, working on various low-power IoT devices. And let's see if we can do this dance of setting up a laptop here. How hard can it be?
Okay, so hello, thanks for the introduction. My plan for today was to present something about device identities and how we can use them on development systems and how we can build really reprogrammable systems on them, what we need and how that all fits together and what are like the requirements for that. Yeah, and then Michael came in with his talk, and that just means that I can skip about the implementation requirements because like we have a solution there, and I pretty much hope that we'll adopt something that comes out of that as a community, and that leaves more time for the fun applications that we can do with that. Still, of that whole original plan, a part that I'd like to keep doing is talk about how setting up initial device identities can work in products. There's a T2TRG draft, that's the research group like accompanying the IETF draft that provides a lot of overview, terminology, etc., which is also why I'm calling it initial security setup and not bootstrapping, which is a rather common but slightly differently used term. And of all the methods that are there, I'd like not to focus on the ones that are that I really personally, and that's really kind of personal opinion, find problematic because they either rely on being local, which is just a matter of how good your antenna is, really, whether you're local or not, and that don't rely too much on any error-prone user operations, just such as reading one pin here, reading one pin there, and then clicking the OK button without actually reading the pin. So how do those identities that Michael talked about get into the device in the first place? And how do those identities that get put in there relate to the operational entities that they use, that their actual operators then work with? Because just because the factory signed some identity doesn't mean that that's necessarily the name that the operator will want to use. So the easiest way, and that is specified, for example, for the lightweight M2M ecosystem and also used in LoRaWAN, is just to say that you do that at the factory. Basically, whenever you order the devices, they only get programmed on demand. We are back again at this stage of like, works for 1,000 devices, works for 10,000 devices, good luck with 4 devices. But that's like reasonably straightforward. A non-zero touch, but I think reasonably like error-resistant way is to use smart cards or SIM cards, which is also something that lightweight M2M supports and what is used a lot in narrowband IoT. And I think we'll hear a bit more about narrowband IoT anyway in a few minutes. The variant that I kind of prefer, because I think it's the most powerful and cleanest, is having an ownership voucher, which is some kind of document that is transferred along the paper trail of buying a device that enables the operator to take ownership of the device and to verify that the device is theirs. That can be as easy as having in the box along with the device a QR code that you scan. But the more powerful variation is that you log in with a vendor along with the credentials with which you also bought the device, and then exchange keys and then enroll the device into your ecosystem. Sure, the other methods, such as a trust on first use that I skipped over a bit, they are viable for many situations. But I'd rather have them as backup. For example, if the manufacturer goes out of operation, I'd rather have a way of as they do with some 3D printers, clip off a part of the PCB. Then the device knows, yes, I don't have to go through my vendor to enroll. I can just my manufacturer to enroll. I can just trust whoever is closest to me, and then take that path from there on. So life cycle, what this results in any of those variations is that in the end the device knows who its owner is, and the owner knows who its device is. Whether that's a shared secret or whether that's a private public key pair in one direction and one in the other, differs from method to method, but for the rest of the talk, I'll be assuming that we'll have an ID very similar to, or basically following what Michael proposed, along with a shared secret that is known and that is maybe transferred from the manufacturer to the operator. The life cycle of such a product would then be it's manufactured, it runs through some initial security setup, then runs through cycles of operations, firmware updates, but essentially it's a one-trick pony. It can do one task it was built for, and that is what many of the things that we see in, like, basically that's what a product is, right? You produce it, you design it, you produce it, you ship it, and it does one thing. In this case, it jumps through hoops. Maybe the hoops can get larger or smaller as the firmware updates, but that's still jumping through hoops. Let's contrast that with what we are doing with our devices. When we usually have anything sitting on our desks as RIOT developers, we take the device, whatever was on there, attach it to the debugger, or even there's maybe even an onboard debugger, erase the flash everything into that, do our initial security setup, and then run it and keep cycling that with whatever application we have. Maybe we even plan the flashing and initial security setup if we pre-configure all the credentials that we'll later need already into the firmware, which kind of works for a situation where I'm sitting on my bench prototyping something. It doesn't work so well if I want to build the images in CI and then send them off to auto update, because that will be a lot of images, and all of a sudden we'll have to implement encrypted suite, and like, I know that exists, but I don't want to implement it. Sorry. Okay. And of course, those are not one-trick ponies. They can do anything that you want them to do. Every time we run them, we run with different applications, and we don't even necessarily care what was in there. What's, I think, not completely accurate anymore is the assumption that we are doing it precisely that way, because that was true when I started working with RIOT. Like, all the dev boards had a debugger attached, and we were always going through that cycle of erasing it and flashing it anew and deciding and like parameterizing our application. So I've taken acquired some data to make plots, and as long as it's like semi-quantitative and subjective, it's not made up numbers, but this should roughly show how my usage of RIOT has evolved, because I still flash things nowadays more often through bootloader, as the blue line indicates. And it's been years since I've last used the make debug target. It's great that it's there when you're doing low-level system development, but building on the network stack, building on the applications, personally, I rarely use it. And I mean, the tutorial we had yesterday was done on boards that don't even have a debugger attached, and that's working perfectly fine. So also with the devices that are provided by manufacturers as dev kits, I think there's a bit of a trend to not rely so much anymore on the debugger. Sure, the big dev kits have it, but when you're a buyer of Thingy 52, the vendors like primary way of shipping, building your applications in there is do an over-the-air update. So maybe we are moving a bit closer with our development workflow to what products look like. I'm just not sure that alone would justify all the efforts that we need to go through in order to make those ID mechanisms and enrollment mechanisms happen. But there is a field of applications in RIOT that we've had around for some time, but only in small numbers and never talked about much. That is general purpose applications. And those general purpose applications would interact perfectly with that kind of enrolling, starting our security, because they serve as a justifying point to build those mechanisms into RIOT and into the boards, and at the same time they are also enabled by having those mechanisms, because it makes their usability so much better. So let's talk about more of those applications that we can flash onto multi-trick ponies, which really many of the boards that we use with RIOT are. So I've put up there a few of the boards that we don't all currently support, but there's there's work going on for like everything of that, at least in RIOT OS or in Arial OS. So the examples would be those LED badges, pixel clock, the Nordic small thingies, which I unfortunately forgot. Really, like any of the more popular dev kits with just attached a few wires, maybe smartphone Bluetooth speakers, which are becoming more easy to port to as we develop better methods of adding new boards, where it's just a kind of matter of like which button is where on the chip we already support. And also those like newer development kits, as the ESP32 thingy here. And on the other axis, I've written down a few applications that can run on multiple of those boards. None of those applications are what at least for those things that are products in the first place, what the manufacturer intended them to run on. But they can all run. And the border router is an example that I've flashed on many of those devices. And it's a useful thing to have there. It's not necessarily the one thing that the build thing was designed for, but this is a hacker community. So if we have a coffee machine and we want to have toast, we just make toast. But that's not the only reason to do that. It's also about environmental impact issues. If a device partially breaks down, you can either toss it or you can repurpose it for something else. And to some extent, I think it's also a matter of like, as a larger community of using computers, how we interact with those. Because from the time the first computers were not even built, but just sketched, people started thinking about more ways they can use them than what they were intended. So like back in Ada Lovelace's days, she already started thinking about music when everyone was building their computers for number crunching, or planning to build computers. So I think having general purpose applications is something valuable and something that we can do as a community, and something that is now easier to do compared to a few years ago, when we did not have good support for over-the-air updates, and also as long as we don't have the means of authenticating devices around such over-the-air updates. I won't go through all the kind of examples what can work for what, but I think it shows that, of course, that's a selection, but still, for each of those boards, there are like half a dozen applications that just like were in the examples list that makes sense to flash on them, onto them. So I think we should work more with those applications. And with the tools that Michael presented, we can go from that flashing life cycle that I've shown here before to something that way more closely resembles what we have in industry. And therefore we can not just enhance the usability of such applications, but we can also train and establish workflows that are closer to what people would later use, because people start with examples. People get started with RIOT, they take an example, they run it, then they have an idea what they want to do, and they start taking the hello world example and modify it from there. And the further we get with our examples, the further we make them realistic, in the sense that they have the security properties that we want for property of like later products, the easier it becomes for people to use them. So once we have a mechanism, as Michael described it, with the addition of not just having the identity of the device in there, but also the credential of the owner, we can have the board flashed once, do some onboarding that basically means, or in the security setup that basically just means taking possession of the device, and then run this circle of iterating through the various tricks that Pony can do in a secure over-the-air update mechanism, instead of always erasing the full device and treating it as like a lab specimen that we treat completely different than an actual device. In the interest of time, because I think I've yes. I'll skip through the full walkthrough of what that could look like from a user perspective. But it should suffice to say that this is something that with a few steps here and there, we could make possible, even for users who just use RIOT as like the platform that simple applications are built that they can then use without ever having to think about whether they have to set up the utility rules in order to connect their device to their laptop. That's all like nice and vision style. What can we do to make that actually happen? And I think there's just a few changes on top of the initial device identities that we'll have to make that would enable this. One thing is right now our bootloaders think in terms of downgrade protection, looking at version numbers of software. If you start writing different applications to a continuously updated program, we'll have to check that more in terms of when did the owner sign off that that's the software we want to use. But as soon as we do the next round updating our suite manifest parser, I think that should be rather straightforward. Same with trust. Whom do we trust to sign those firmware images? We need both the verification from the original firmware author and from the from our operator. But again, that is something that is already part of the suite specification, so it should be straightforward to add that in. Configuration is something which we should might talk about during the hackathon, because not all the configuration that is suitable for one instance of a device might be suitable for the same device with different firmware. But that's something to try out. Maybe not even all applications would need that in the first place. Network onboarding is something that too we don't have yet, and we can enable based on having device identities. There are plans both for 802.15.4 on our roadmap already, and there are patches for host APD to enable similar kinds of enrollment over Wi-Fi. And then all that's missing is to actually write the application. So of the big list, we have two that I think are already ready to use, which is the border router and the doorbell button, because if you want to connect to those things with co-op, it's just really the Rust Sol example gives you all the things that you need to hook this up to a doorbell. And we have pull requests for more general purpose audio stuff in RIOT, and we have a pull request for having a more general purpose clock, like something you could flash onto anything that has network and a display in Arial OS. So yeah, let's see where we can get there. This is, just as Michael's talked before, not a full proposal, not even a minimal proposal. Let's just catch a direction which I think that the community should move based on the developments that we have in the area of security. But I think it's doable. So let's make that happen. Let's do more general purpose computing on devices where some people think it's not possible. And yeah, let's make them all as fabulous and versatile as Ponies want to be. Thank you. Questions? Comments? I'm sorry about the encrypted firmware stuff. It just had to be.
It's not a conventional. No, the issue that stuck in my head was this configuration question, and how does the configuration that get there? Is that sort of the flash operation, or is it more like a storage operation, an API operation, or even a protocol operation? Which you need in Microsoft's proposal and also in yours. And specifically on the factory side, I once, years ago, I created, obviously I was facing the same problem in your diagram when you had the flow of arrays like the factory and then secure provisioning, then this one, yeah. It's actually a little bit more complicated because in the factory, not for the developing kits, but in the factory run, you initially do a lot of testing as well at different levels. Yeah. And then when the thing gets set up, there's actually the phase which you need for security. You need to you don't want to just write the private key and certificate there because for security reasons, you don't want to expose the private key. So if it's properly done, what you want to do is you want to, like in the steps before, you want to boot up the board, you want to have the board run through some program, and you actually want to have a protocol, an exchange that basically does something like a CSR and gets a certificate there. And alongside that, you can also provision configuration information here. And then you swap out that provisioning software against the real software that you would use afterwards. So, and then back then I wrote such a protocol because that's what the scripts get then put into machines in a factory, and that's what you run. It's one of the many things to run when you develop microprocessors or chips in general.
Yeah, I envision that it would probably run a bit similarly here, depending on the capabilities of the device. Then the keys might be stored in different places, and in either case, no matter where they're stored precisely, I think that mainly this will be about device identity and owner identity, and only when the device is really enrolled into the system of the operator, then they can start making actual decisions on like operational parameters. So whatever happens in there, it's way more than just like going through the factory, or a lot of things happen in there, but the end result is there's an identity of the device somewhere, there's a certificate on that identity, possibly not even on the device, and the device knows like whom to trust. I think that's the essential outcome. And yeah, the processes there are more complicated here.
And thanks again, Christian.
Thank you.